Good morning from Mission Control Houston. Thanks for waking up early for this momentous occasion as we bring you live coverage now of the expansion of the first ever human-rated expandable structure to be flown into space. Just right now on board the International Space Station, the steps begin expanding the Bigelow Expandable Activity Module, a partnership between Bigelow Aerospace and NASA to fly the first ever human-rated module to the International Space Station for an important technology demonstration. As we begin our show right now on board, NASA astronaut Jeff Williams kicking off the deployment sequence with the beam deployment controller. We're going to be following along over the next several minutes, hour or so throughout all of these dynamic activities. And we're going to be following about basically 5 major events with the expansion of this module.
I got ABV success, Fox.
Houston copies.
And again, as we are joining this operation right as it's beginning, Jeff Williams going to be going through a number of steps just now. There are 3 steps right off the bat with the deployment controller.
Houston copies and concurs. Stand by, Jeff.
And throughout this operation today, you're going to be hearing NASA astronaut Jeff Williams speaking with NASA astronaut Jessica Meir. She's just there at the bottom of your screen. Just next to her is NASA Flight Director Brian Smith, who's going to be leading the team down here on the ground through all of the operations today. And again, we are joining just as these operations are beginning. Jeff Williams inside of the Tranquility node, to which the Bigelow Expandable Activity Module, or BEAM, as we're going to refer to it throughout the broadcast today.
1.701 is in work.
Houston copies.
And so again, the first step of our operation has already been initiated, that beam deployment controller kicking off the first 3 steps, the first of which was the closure of what are known as ascent vent valves. You'll hear them referred to as AVVs, and these are valves that have been open since the module launched in the trunk of Dragon and need to be closed in order for beam to hold the pressure that will soon be introduced when the air starts flowing into the expandable module. We got confirmation that that first step did go successfully. The second step is the cutting of restraint straps that are around beam itself, and we're there just to ensure that it's in its pack configuration from launch all the way through installation, which it's been installed since mid-April. And with that, there was a known chance of the pyros holding those straps in place could not fire, or they could fire and the controller may have gotten a false negative. So Jeff Williams now going through steps to basically use tools on board to just make sure that those pyros did fire successfully and those restraint straps were released. And again, you'll be hearing calls consistently between him and Capcom Jessica Meir throughout all of our operations today. And then once we get confirmation that those straps were detached successfully, step number 3 will kick in, and that will be the release of the forward bulkhead from the aft bulkhead. Basically, there are 4 struts connecting the 2 together that have been taking all of the launch loads, all of the loads on the module itself from launch all the way through installation and where we sit now. And then a number of bolts on each of those sides will need to be released, and then the expansion will be able to begin. And then the physical expansion itself will be done again by Williams, actually manually inflating this module using first air from the International Space Station itself. And he's going to be opening up a valve for intermittent intervals, so anywhere from a couple of seconds to 30 seconds to even a minute at a time, depending on the feedback that he gets from the ground. And now initially these small inflation bursts will be very short, only several seconds in time as the module begins its initial expansion. And then Jeff will call down after taking pressure readings, feeding those values to the teams down here on the ground with the flight controllers at the ethos console and the flight controller at the robotics console, taking those values, feeding them into what's known as a pressure curve plot, basically a plot where using all of those values, they can then calculate how long the next inflation period should be. And then Capcom Jess Camille will call up to Williams and instruct him just how long to inflate again and or introduce additional air. And again, this process could take up to 45 minutes or more. It needs to be done with constant video communication, as there will be an overlay that will be able to show you where beam will need to expand out, increasing its length by 68 inches. And you'll see a number of lines on that grid once we get that video communication back. And expected to inflate out to 68 inches, as far as 73 to get to its final length. Again, that packed length right now, 85 inches, will ultimately expand out to 158. And beam, once the full expansion complete, going from a volume of 127 cubic feet all the way out to 565 cubic feet. So a very big step up in size for this module from its packed configuration to that full expansion. And again, that expansion will be completed once the module has expanded out to that size, and they can confirm that the series of stabilization struts inside basically have locked into place, and the module will be able to hold its shape. At the actual expansion, the pressure inside of beam will only be about 0.4 psi, so not very much pressure required for the module to actually get its expanded shape and to hold that shape as well. And then following that, the pressurization of the module itself will begin. And that will be done by a series of air tanks, 8 air tanks inside of the module. And those will release air inside, pressurizing it up to the same atmospheric pressure as the rest of the International Space Station. And they can again introduce air from the station itself into beam, just in case the air in the tanks isn't quite enough to get it up to that 14.7 psi, the same atmospheric pressure that we have at sea level here on planet Earth. It's the same they enjoy inside of the cabin on the International Space Station. And then once that pressurization is complete, deployment will be finished, and the crew will begin another series of checks on the module itself and the vestibule in between it. That's just the small space in between the hatches on beam itself and the Tranquility node to which it's been attached for the last month and a half. And then all of that ultimately setting up for the first time the crew members will be able to go inside of beam. That's currently scheduled for June 2nd. And again, right now, Jeff Williams going through some optional procedures that were already timelined out by the crew just to make sure that these pyros, you may hear them referred to as NSIs, which is NASA Standard Initiator, basically just a pyro that can be fired and then release those restraint straps, which have been in place since beam launched inside of the trunk of a SpaceX Dragon. And so we'll continue to stand by and follow along with those procedures. Should get video communication back with the International Space Station any moment now, and we'll be able to ultimately watch beam as it expands. And again, we'll show you that grid.
To the other multimeter kit. All we have is a multimeter here. We don't have the accessories required.
Okay, stand by, Jeff.
And Capcom shortly going to tell Jeff Williams where to find all those items.
Should be in the vacuum access jumper bag, 1.0 CTB 1256.
Okay, I'll look again.
And again, NASA astronaut Jeff Williams going to be basically at the controls, hands-on for all of this expansion activity this morning. While we wait for a lot of this to resume, just to continue to dive in a little bit more in depth on BEAM, a very important technology demonstration taking place on board the International Space Station. An example of expandable habitat, something that can be much lower mass and packed much smaller, taking up less volume for launches than traditional metallic habitats, which comprise the entirety until BEAM of the International Space Station, being looked at as an important technology that could be used on very long duration missions of the future. As we continue to look to head out to Mars, there are a number of challenges that NASA and all of the other interested parties are continuing to work to try and solve. And then before we ever send the first astronauts, several rockets will launch with cargo, supplies, and then deploy to await crew's arrivals. These expandable modules, which are lower mass again and take up less volume on a rocket, could increase the efficiency of these cargo shipments and then reduce the number of launches. And then expandables also being looked at as potential concepts for habitation capability in cislunar space, the area between Earth and the Moon, with applicability in in-space transit habitation.
The test adapters, and we have the wires, and we have what we think will work to measure across these pins.
Okay, we copy.
So again, right now, Jeff Williams inside of the Tranquility module. We're going to see him in there throughout the operation today. Beam currently attached to the aft port on the module. It's the same one that has the cupola attached and also the permanent multi-purpose module, the large storage section on board the station, also the crew's exercise equipment and one of two station toilets on board. And again, right now we're in this step where Williams is going to be manually measuring whether or not these pyros successfully fired. This is step 2 in the 5-step process of expansion today. And again, step 1 done successfully, closing those ascent vent valves. Those were valves that were opened or were left open during all of the ascent to orbit, being kept at a vacuum, so no pressure inside. These valves now closed, enabling the module to hold pressure. They'll get an extra layer of redundancy when the crew will install caps once they go in for the very first time. Again, that first ingress, as we'll call it, scheduled to take place on Thursday, June 2nd. And once this step is completed and Williams is able to confirm that those restraint straps were cut, they can then reinitiate the controller. Every time they run it, it'll go through all of the different steps over again. So it'll once again confirm that those valves are closed and then the restraint straps were cut. And then step 3 will initiate, and that'll be the release of the bulkhead.
Yeah, Jeff, the pin kit is in PMM. That's the 1.0 CTB serial number 1096. So that's PMM 1, overhead 2, delta 1.
And there are 2 pin kits in that CTB. Can you specify which ones we need?
Either one should work, Jeff.
And we'll have several views of beam itself once it expands. One of the best ones coming from just in the tip of the robotic arm, Canadarm2, which was used to install the expandable module back in April. We'll also be able to show you an overlay, a robotic overlay, showing a grid of just how far beam is expanding. This being used by the robotics officer here in Houston.
And Jeff, just a heads up, you should first try the 16 gauge as specified, but if that's not a good fit, you can use the 20 gauge.
Copy.
And again, that overlay view showing a grid of just how far beam will be expanding. First lengthwise, we'll be looking to expand it out 68 inches at least beyond its current packed configuration of 85 inches in length. Ultimately, once everything is expanded and pressurized, beam should be 158 inches in length. And again, you'll also see it expand across its diameter, going from 93 inches to 127 inches in diameter. One of the interesting aspects of this expansion is there are a number of expansion scenarios, so a number of shapes that beam could ultimately take during this initial expansion period when Williams is manually flowing air into beam from the station itself. But again, right now, Williams on board working through step 2 again. This already on the timeline just in case this step had this issue, so he'll work through to get some manual readings to make sure that those pyros are firing successfully. Then we'll be able to kick off the expansion procedures once more and then eventually set up for that manual inflation. It was originally targeted to begin at about 5:10 a.m. Central Time, so still right on the timeline, and should be plenty of daylight. The station actually in what's known as a high beta angle, so almost near constant sunlight for several orbits today. There should be just a short sunset and sunrise coming up, but for the most part, the station going to be in almost constant sunlight, so plenty of light for the teams on the ground to monitor beam's expansion, which was a requirement, and also plenty of video communication with the station through our tracking and data relay satellites, allowing them to track from down on the ground. And again, this manual inflation process will be a tandem effort with Williams taking consistent pressure readings after each introduction of air into the beam module, and then that will be fed to the flight controllers down here on the ground, who will feed that into a plot and then radio back up the length of the next introduction of air. Again, Capcom, Jess Camille are going to be chatting very frequently, relaying a lot of instructions to Williams as he works inside of the Tranquility module on this manual inflation this morning.
In Houston, for NSI-1, I show a value of 5.68.
Copy, Jeff. And Jeff, could you confirm your units, please? I think we see mega ohms.
I've got it in the ohms position, and I do read an M before the ohm sign.
Okay, copy.
And again, there were 3 pyros set to fire. You'll hear them referred to as NSIs, which stands for NASA Standard Initiator. And again, those 3 pyros were meant to cut the restraint straps holding beam in its packed configuration. Step 2 of 5 for our operations this morning. right now Jeff Williams using a multimeter to just get manual readings on whether or not those pyros fired. And then once they confirm all of those values line up, they'll begin to or be able to continue the expansion process. And so this process could take up to about 30 minutes, getting us then back into the flow of procedures and then onto that manual inflation step where beam will start to take shape.
3.84 currently.
And Jeff, if you don't mind confirming the units with each measurement since the multimeter is in auto range.
3.85 mega ohms.
Houston copies.
NSI 3 is 0.729 kilo ohms.
Houston copies.
And Williams continuing to take these multimeter readings on those NSIs, again, those pyros that were meant to fire to release the restraint straps that were in place.
310.8 ohms.
Houston copies.
NSI 5 reads 94.4 ohms.
Houston copies.
NSI 6 is 146.3 ohms.
Houston copies.
With your concurrence, we'll go back and remeasure NSI number 5 just to confirm.
Houston copies.
And repeating NSI 5, it reads 94.7 ohms.
We copy.
And so at this point, all 6 NSIs, or those pyros, have been measured. There's 2 per strap. Again, there's 3 straps in total. So the team's now looking at all of the readings that Williams was able to take, and then we'll soon be relaying instructions on where we are now in our procedures, whether we're ready to proceed with the expansion.
Okay, Jeff, good news. Those values confirm that all 3 straps have been cut, so you can continue in step 2.7.
Copy, we're continuing.
And so Jessica Muir delivering the good news.
For your essay, we can verify that we have good cutting on all 3 straps because we did have redundancy in those pyros. So both values 4 and 5 are for the same strap. So since 4 passed and was greater than 100 ohms, we know that we're okay and all straps are cut.
Okay, very good. Thank you.
And again, Williams getting the call. There were 2 pyros per strap, 3 restraint straps in total holding beam in that packed configuration, and that multimeter confirming that all 3 straps have been cut, so step 2 was done successfully. And at this point, we'll be able to pick up on our procedures, kicking off again with the deployment controller. Again, those ascent vent valves already successfully closed and now confirm the restraint straps have been cut. Next up will be the release of the forward bulkhead. So there are 4 struts connecting the forward and the aft bulkheads, basically the 2 big ends of on beam. And those will need to be released so the actual expansion can take place, as these bulkheads holding, or these struts holding the 2 bulkheads together are there. They've been taking all of the launch loads essentially and holding them together. There are 4 bolts holding these struts together, and each of them needing to release. Each one will talk to the controller. These can also be done manually, again, if any hiccups come from the controller, but that'll be the next step. And then after that, the manual inflation of beam, and it will begin to take its final shape.
So I'm looking to see where I go next.
We copy, Jeff. Stand by. And Jeff, with that, you have a go to pick up on the next timelined activity, and that's again the deployment controller. So it's 3.5, step 3.5 of 1.302.
And with that, Jeff Williams getting the go to proceed, go back to where they were on the timeline, and begin or resume the deployment procedures.
3.5 of 1.302.
Affirm.
And once the forward bulkhead gets released, the manual inflation of beam will begin. and that expected to take up to 45 minutes. Again, it'll be a very incremental process of Williams gradually introducing air from the station itself through a valve into the expandable module. Williams will open the valve for just a few seconds at a time, especially to begin with, and then close it, take a pressure reading, and call that down to the flight control team here in Houston. After that, the ethos position and the robotics officer will take the data and compare it, and then give Capcom a number that will be radioed up to Williams for how long he should then open the valve again, and it will just be this repeating process until Beam has expanded out to its length, to a length of an additional 68 inches, bringing it just a few inches short of its anticipated final length of 158.
Houston copies. Okay, Jeff, you have a go for the next activity again. That is table 1 and 1.303.
Copy, reinitiating table 1 and 1.303. I got AVV sequencing.
Houston copies.
Again, the Beam deployment controller now running again through those first 3 steps. The ascent vent valves already confirmed to have closed, those 2 redundant valves that needed to be closed in order for Beam to keep pressure. There, the message again, the AVV success. Next on to, again, confirming the restraint straps.
We copy.
RSC success, Fox.
Houston copies and concurs.
And this time getting that success on those restraint straps.
And I got an audible.
We copy.
FBH success, Fox. ISV sequencing.
Houston copies.
And step 3 complete. And with that, the first 3 automated steps from the deployment controller completed. Next up is going to be that manual inflation. We'll start to see Beam take shape. And they'll wait just a few moments until Videocom comes back with the station, because again, the teams down here on the ground needing to follow along on that plot just to make sure that they're aware of just how far along in the expansion Beam is, as they'll be feeding up the times, the amount of time that Williams needs to hold that valve open to introduce air from the station itself over to Beam. Again, this is step 4 of 5 in the overall deployment for today. The first 3 now done successfully, and so now step 4 kicks in. This is expected to take about 45 minutes or so,
okay,
and
Jeff,
will expand Beam out to its...
And you can pick up in 4.2.1.
Will expand Beam out to its final shape. And again, this view from the camera right on the tip of the Canadarm2 robotic arm going to be probably our best view of the expansion.
That's still in table 1 of 1.303. You do not need to wait for the sequence to complete, so you can pick up with 4.2.1.
Okay, I understand that's 4.2.
Yeah, Jeff, so in table 1, you were in 4.2, and now you can see the ISV sequencing. You do not need to wait for that, so you can continue to 4.2.2.
Okay, got it.
And so Williams powering down the deployment controller for now. And it'll get powered back up once it's time to pressurize beam following this manual inflation activity. And as you can see, the sun starting to set. It'll only be set for a couple of minutes on the station, but they'll probably wait until the end of this pass.
Stand by, Jeff. We're coming up on eclipse, so we're going to have to hold for that. Our estimated time to pick back up will be 10:10.
Copy.
And again, daylight being a requirement for this expansion operation, so they'll stand by just for the next 3 minutes or so, 10:10 GMT, 5:10 a.m. Houston time, so right on the timeline for when the expansion was expected to take place. And again, the station in a high beta angle, so basically in a state of almost constant sunlight. Following this eclipse will be several orbits around the Earth, potentially with no sunset for the station, so plenty of sunlight for the rest of the operations. Also plenty of both voice and video comms, so we should have an unbroken streak of operations following this next sunset. So we should be back in about 2 minutes with full sunlight, and then the expansion will resume. And again, we're in step 4, the manual inflation of beam, with Williams manually introducing air from the station itself into beam. And once that's finished, the internal pressure of beam will only be at about 0.4 psi, but still able to hold that initial shape, as it will be in a vacuum, so no pressure pushing in on it from the outside. And all of that will set up for the ultimate pressurization up to cabin pressure with the rest of the International Space Station.
The actual dynamics of the beam module. If you could give us a heads up prior to the appropriate steps of what we might expect visually, that would be helpful, I think, for the entire crew.
Okay, Jeff, copy. We will do that for you.
So again, just standing by a couple of minutes until the sun fully back up. And good daylight for the teams down here on the ground to follow along with the manual expansion of beam. And all of this setting up, of course, for the first time that the crew will go inside this, the first human-rated expandable module built by Bigelow Aerospace and flown on a SpaceX Dragon and installed on the International Space Station. The crew scheduled to go in for the first time on June 2nd, so just about a week from now. and the crew ultimately going to be responsible for installing a number of sensors, but of course all of that done a week from now after the expansion and leak checks completed.
4.6 and then subsequent steps in 4.9 as we cycle through. We're not sure how many iterations that we'll need to get to our full volume, but we'll be going through that a few times.
Okay, I understand. Yeah, I was trying to remember. I thought that there was enough potential energy that was going to be released that we would get deployment before pressurization, but apparently that's not the case.
Right. With the manual inflation, we will get to a larger value, and then we'll go to the final pressurization, which will again increase it slightly.
Okay.
Capcoms go.
Flipped.
Okay, Jeff, we are go for manual inflation. You can pick back up in step 4. And that'll be for you step 4.2.
Okay, 4.2 is complete, and the ISS crew is ready for beam inflation.
And so with that, the manual expansion of beam now set to begin. Jeff Williams going to be slowly introducing air from the station itself into the Bigelow expandable activity module.
4.4 through 4.6.
Copy, initiating inflation.
And again, this is going to be done in a very incremental process. That first introduction of air only being for about 5 seconds. And then throughout this process, Williams is going to be taking pressure readings and then feeding those back down to the teams here in Mission Control Houston, who will then come up with the next amount of time that he needs to introduce air into beam, and this process just done incrementally over time until the module again expands out an additional at least 68 inches as far as 73, which will be its final length of 158 inches.
For 4.5, I do read 8.1.
We copy. Please stand by, Jeff.
Standing by. I currently read 14.0.
Copy. And Jeff, please hold here for a moment.
Holding.
And Jeff, did you complete 4.6 as well?
Affirmative.
Copy.
And so Williams beginning the deployment process. He's opened the valve for just a couple of seconds. If we look at the grid, we can see that beam has moved just very slightly past that initial line. Again, this is going to be a very incremental process to expand it out all of the way, taking about 45 minutes.
5 seconds each time.
Copy. 2 times, 5 seconds each. Okay, Jeff, that puts us at 4.7, which is a ground step, so stand by.
Goodbye.
So now the team's here in mission control looking at the data that's been sent down, the pressure reading sent down by Jeff Williams, and they'll feed that into what's known as their pressure curve plot. And then Ethos and the robotics officer will work together to convert how long Williams then now or next will need to open up the valve to introduce an additional amount of air into beam. And that'll be relayed to Capcom, which will go up to Jeff, and then we'll just recycle that process over and over until beam is fully expanded. So it'll be this iterative process where we'll stand by for a couple of moments down here on the ground while they do their calculations, and then Williams will again open up the valve and begin this expansion. Again, the module did jump ever so slightly out to a slight, maybe an inch or so beyond its original point, so the expansion has begun. It'll be a slow process, but expanding out a total of 68 inches or more, all the way out to 73 inches by the time this is all completed today. And this is a view again inside of the Tranquility module at the hatchway.
We have seen some expansion of beam, and we're assessing right now.
Copy. Standing by.
This is a view again of that hatchway to beam, which will be opened up a week from now following a successful expansion. And the first ingress, the first time the crew will go inside, will be a week from now on June 2nd. No lights inside of beam, so the crew will use battery operated flashlights to go inside when they set up all of the sensors, which will be their primary purpose for that first ingress. And these sensors over the next 2 years will be measuring radiation exposure as well as temperature changes to the external and internal structure of beam, and also monitoring for any MMOD, micrometeoroid, or orbital debris impacts to see how the module holds up. Again, rated to the exact same specifications that we have rated all of the metallic modules, and beam itself actually placed in a part of station, also smaller when compared to the other station modules, that significantly reduces the risk from MMOD to beam.
So Jeff, while we're assessing, just to repeat that big picture, we're going to be going through a series of iterations, opening and closing that sampling port. So each time we'll be providing you the value of how long, and then we'll be asking you for that pressure reading.
Okay, I understand.
Okay, Jeff, you can now pick up in step 4.9. The first iteration for the ISO sampling port will be a duration of 4 seconds. That's 4 seconds.
Copy, 4 seconds. Four seconds complete. The valve is now closed. Pressure 17.1.
Houston copies. And Jeff, keep an eye on the pressure and let us know if it stays stable there or if it continues to increase.
Currently the pressure is 17.0.
We copy.
And so another quick burst of air into beam. The robotics officer reporting that first bit of expansion, 3 inches in length, 5 in diameter. All of this kicking off right at around 5:10 a.m. Central Time, 6:10 a.m. Eastern per the timeline. Williams just completing another opening of the valve, this time for 4 seconds, and the teams will once again do their calculations and get him a time for the next opening. Again, as we continue to see beam slowly expand over the next 30 to 40 minutes or so. And this step 4 of 5 in today's procedures, once beams all the way expanded to at least that additional 68 inches, we'll be able to move into the pressurization where the 8 air tanks, which are inside of the expandable module, will be opened, releasing air to pressurize the module up to that atmospheric pressure that the station itself is in. It takes about 42 pounds of air to bring beam up to its full pressurization, and that can come from those tanks. It could also come additionally from the station itself, but that expected to be the final step today. And again, we'll continue to get a couple of external views from the robotic arm and the cameras on the station structure itself as beam will slowly creep out and expand to this full size. Again, going from an internal volume of 127 cubic feet to 565 cubic feet during the operations today. So a very significant increase in size.
And Houston, just to add to your essay, on the second inflation of 5 seconds, I did hear a very distinct audible sound from the other side of the hatch, something given loose.
Houston copies.
And so Videocom coming back shortly, should get the next call for the next introduction of air shortly.
Okay, Jeff, we're ready for that second iteration, so that sends you back to 4.9. This time, open only for 1 second. 1 second.
1 second, 4.9 in work. The valve is closed. Pressure is 17.4. It was 16.8.
Houston copies.
And as we continue to stand by for the next step to continue expanding beam, just a couple of cool facts about the module itself. Again, it's going to ultimately expand out to a internal volume of 565 cubic feet, weighing in at 1,415 kilograms in total. The air inside of the module itself, once it's fully expanded and pressurized, will actually recycle fairly quickly. The air going to be turning over every 39 minutes, or about 3,000 times a month inside of beam. And there won't be any hardware or storage inside of the module itself. Instead, there will be a series of sensors that will be placed throughout to measure dynamic loads and radiation and temperature and other important data that will be fed into a laptop that's downlinked down to the ground for the engineers to continually review over the next 2 years.
Jeff, could you give us another pressure reading, please?
17.3.
Copy.
So getting a report, the diameter of beam expanding another 2 inches, 0 in length this pass. Again, the exact shape that beam will take throughout this process is unknown. There are a number of expansion scenarios.
Jeff, you have a go for 1 second. One more time. 1 second.
Copy, 1 second.
Williams getting the call for another 1 second burst of air into beam.
Pressure's 17.2.
Copy.
Valve is closed. Ending pressure 18.2.
Copy.
And again, that grid overlay that the robotics officer here in Houston using to measure just how much beam is expanding each time we introduce a little bit more air into the module. And that being used with the pressure readings to then determine the next length of time that Williams will be opening that valve to put more air from the station into beam itself. Beam and an important technology demonstration, one of many taking place on board the International Space Station. This one with some direct applicability to future long-duration missions, future habitats for areas around the moon or even onto Mars. NASA partnering with a number of companies in the commercial industry on the development of advanced exploration systems such as habitation. Bigelow Aerospace, actually one of 4 commercial companies working with NASA through the Next Space Technologies for Exploration Partnerships, Next Step, to provide conceptual studies for how habitats could be used for deep space requirements.
And Jeff, could you give us another pressure reading, please?
18.0.
Copy.
And hearing that last second burst, giving another 5 inches in length to beam, 2 inches in diameter, so continuing to move along in the process, again very gradual to get it out to that additional 68 inches in length, ultimately all the way out to 158 inches once it's fully expanded. And again, for now, the team's assessing the pressure readings, comparing that to how much the module has expanded so far, both in length and in radius. And then following that, radioing up another length of time and more instructions for Williams.
And Jeff, just to give you a heads up, the reason why we're waiting here, we're slightly above our safe pressure curve. So we're waiting to see if we get a slightly lower reading before we can continue.
Okay, I understand.
So the team's just waiting for the pressure to settle a little bit before they give Williams the call again to begin reintroducing more air into beam. The engineering support team here in Mission Control Houston working in tandem with engineers from Bigelow Aerospace.
Affirm, Jeff. That's a good view. Thank you.
And again, just standing by here, the teams in Mission Control Houston looking over the data, making sure that everything lines up before they give Jeff Williams the go to continue this manual inflation of the Bigelow Expandable Activity Module. So again, just standing by a few more moments. The teams again waiting for the pressure in beam to settle out before they continue the gradual expansion process. This entire thing expected to take 45 minutes or more, as it is these very slow, very short, gradual introductions of air into the module from the station itself. Again, NASA astronaut Jeff Williams standing by inside the Tranquility module.
Thanks for your patience. We're still discussing our safe pressure curves.
Okay, thanks for the status.
And throughout the expansion process, the team's just needing to make sure that the pressure readings inside a beam are consistent with how much the module has expanded, both lengthwise and across the diameter.
And Jeff, the multimeter has timed out, so you can just power cycle it from off back to your setting there. Thank you.
And the team's here taking one more look at the data. Going to be getting a call up to Jeff Williams in the next minute or so. Again, in the room, Flight Director Brian Smith leading all of the folks down here on the ground who are working in tandem with the astronaut to expand beam today.
Okay, Jeff, you have a go to open the port for one more second.
Copy, 1 second.
And a generous 1 second.
Understand.
And so Williams getting the go to once more open the valve, introduce a little bit more air into beam. And the team's hopefully getting a little bit more expansion both along the length and the diameter.
From 17.7, the pressure is now 19.5.
Houston copies.
And I had no audible indication on the other side.
Copy.
And with that additional second or generous second of air, the pressure now up to 19.5, and it'll settle over the next several minutes as again the robotics officer now analyzing any increases in the length and diameter of beam. And they'll once again compare that to their safe pressure curve plot, that plot that they're using to inform them on how much or how long the valve should be open to put more air into beam from station. So once more in that short holding pattern, hopefully. Hopefully the module expanding out a little bit more, and this process will eventually pick up beyond these 1 second introductions of air. But for now, we'll go ahead and stand by for a few moments while the teams here in Mission Control, again, mull over that data and then get some more info back up to Jeff Williams on board.
And stand by, Jeff. We're still assessing those safe pressure curves.
Copy, standing by.
The teams here in mission control and the mission evaluation room down in the MER, the engineering support teams looking again at all the data now and whether or not they'll be able to continue this expansion and how much time they'll give to Jeff Williams to introduce another burst of air into beam. And just a reminder, daylight and solid video communication required anytime this expansion gets the go, so the teams down here on the ground can monitor and calculate the values of expansion both in the radius and the length of, or the diameter and the length of the module as this expansion process takes place. Daylight not going to be a concern for the space station today. We will have video comm only for the next 10 to 15 minutes or so, and then there could be a gap and we'll have to pause. But for now, the operation continuing. Again, it kicked off at 5:10 a.m. Central Time with Williams opening the valve for the first time. And again, we're just continuing to stand by while the teams in mission control look over the data, the latest pressure readings, the increase in size that they're getting from that overlay from the robotic arm, and just looking over the data and what the next steps are going to be to continue with this expansion of beam today. And just to recap, the team's
and Jeff,
looking at the latest
again.
pressures.
So last time we were just close to the limit of the safe inflation curve, and now we're actually a little bit above, quite a bit more above it. So we are assessing where we are with the axial and radial displacement, and we're not exactly where we think we should be. So that's why we're talking things down here. Thanks for your patience.
Hey, Jessica, thanks for the status.
And that quick status from Capcom Jessica Mir. Again, just relaying, the teams here still looking at the data. They're a little bit above that safe pressure curve that they're using to plot out and then determine the amount of time Williams needs to open the valve for the inflation or the expansion of beam. And they're just going to continue to discuss for the next couple of minutes, come up with what their next steps are going to be, the next instructions up to Williams on board the station. The first 3 steps were done successfully earlier this morning with those ascent vent valves being closed, the restraint straps cut through pyros, and the forward bulkhead being released. And now we're in step 4 or 5. This manual inflation was originally expected to take about 45 minutes, going a little bit slower today as the expansion not going exactly according to some of the preliminary plans, but the team is looking at the data, seeing what they're able to do to continue this expansion process today. And then again, once beam fully expanded out following this initial inflation, the pressurization will be that final steps with the air tanks inside of beam opening up, and just to pressurize it to the same level as the rest of the International Space Station. Following that will be a series of leak checks, one long, one 80 hours in length over the weekend until the eventual first ingress, the first time the crew members will go inside of beam, currently slated to take place on Thursday, June 2nd. Continuing to stand by here from Mission Control Houston, the teams again assessing next steps, looking over the data a little bit above that safe pressure curve
So Jeff,
in
it's
terms
probably going to be about another 17 minutes since we're coming up on another pass here, 275 pass. So if you want to go take a look at that overlay, I can talk you through what we're looking at if you want to increase your SA there.
About the overlay that's being fed up to us on VC.
Okay, so if you're looking at it right now, basically, if you look at the grapple fixture, where we're measuring for the axial displacement, it's where the pin meets the base plate. So right now we're at 5 inches, and we need to get to 68 inches to complete the manual inflation. And then for the diameter, we're currently at 96 inches, and we need to get to 127 inches.
Okay, understand. This is where those straps have to be overcome, right? Where they're going to snap the attenuation straps.
Yeah, Jeff, that's right. Those are those rip stitch straps, and there are a few different points, and we are getting close to the first point for that. Could you describe the noise that you said you heard earlier?
I don't know if I can describe it other than to just say it was a bang, and it was, as I recall, a fairly distinct single bang. But, my memory on its details are, I don't know if I can describe it in detail.
Okay, we copy.
And the team's continuing to talk things over what they're...
We believe it was just the shear pins on the bulkhead, so that actually was as expected.
Okay, good to know. Thank you.
And that real quick, just an explanation of the noise that Williams had reported hearing, being a set of 4 pins that were expected to detach all at the same time, so that noise was expected. The engineering teams down here on the ground confirming. But again, the team's looking over all of the data, looking at next steps for this expansion process. We will lose video comm with the station momentarily, and there will be about a 17-minute gap until that good video signal locks back up. So there will be a pause in the operations. We'll just stand by for a little while until things resume here while the teams again continue to finalize their decisions, look over, and determine what the next steps are going to be for this expansion. Again, it kicked off just about an hour ago at 5:10 a.m. Central Time. The first 3 steps of a 5-step process today being confirmed successful. And then Williams right now in step 4, this manual expansion of beam, slowly introducing air from the station into the expandable module itself. At a bit of a pause right now as they are above what's known as the safe pressure curve. It's a chart that they're using where they're comparing the pressure readings inside of the module to how much it is expanded out both lengthwise and diameter. And as we heard Capcom Jessica Meir explain, going from its packed length of 85 inches all the way out to 158 inches today, the diameter going from 93 all the way out to 127. And just a few inches so far on beam's expansion, so still very early on in the process. The team's looking at what their next steps, what options are available before they tag back up with NASA astronaut Jeff Williams, who's again being the hands, the eyes, and the ears for everything on board the station for this process today. And right now we are in that gap with the video communications, so operations for the expansion will pause for a little while. Should start to get signal back at about 6:21 Central Time, so in about 10 or 11 minutes, and it'll lock up solid at about 6:25 for another extended pass. And so we'll just continue to stand by while the teams discuss, and then we'll pick back up with today's operations to expand beam. Again, the first human-rated expandable module ever flown into space. Looking forward to getting it hopefully still expanded today. All that setting up for that first ingress, the first time the crew will go inside on June 2nd. So we'll just stand by for the next couple of minutes and then come back to you when operations resume. And for those of you just now tuning in to the expansion of BEAM today, just giving you a quick update. We're in a holding pattern while we wait to acquire video back with the International Space Station, a requirement for all the expansion operations in the steps that we are currently in. The engineering teams here in Mission Control also still looking over the data, the pressure inside of BEAM, and also how much it's expanded both across its length and diameter so far. They are a little bit above what's known as the safe pressure curve, so that plot that they're using to help determine how long Jeff Williams should then introduce air into BEAM from station. And so looking at what the possible causes are and what any remediation available to them, what their next steps are going to be to see if we can continue along this expansion process, which kicked off a little over an hour ago at 5:10 a.m. Central Time, 6:10 a.m. Eastern. So just continuing to stand by. Again, we should lock up with good video comm in the next 10 minutes or so, and then hopefully get some words up to Jeff Williams on where we stand with this operation and what the next steps are going to be. So just continuing to stand by for just a little bit longer from here in Mission Control, hopefully getting back to BEAM in the minutes to come. And getting that video comm back with the International Space Station. There might be a short handover in a minute or so, but should be locking up and hopefully getting back to the expansion operations in the not too distant future. This again, a view from right down the end of the Canadarm2, the robotic arm that installed beam back on April 16th, once it was removed from the trunk of SpaceX's 8th Dragon resupply mission, which brought it to the International Space Station unpressurized. And again, we're in step 4 of 5 today, the manual inflation of beam, with Jeff Williams slowly passing air through a valve from station into beam. We've been paused for several minutes while we waited for this video to come back, and also while the engineering teams here in Houston, both the NASA teams overseeing the station and teams from Bigelow Aerospace who are working with them down in the mission evaluation room, the MER, to decide next steps for this expansion process. The pressures that they're seeing inside the module a little bit higher than where we were expected to be in terms of how much it's physically expanded, both along the length and the diameter. So the team's again looking over that data, discussing all of the options and what the next steps will be to continue this expansion procedure.
And Jeff, if you could recycle that multimeter again, power cycle that one more time, that'd be great.
Go.
continuing to stand by here in Mission Control Houston. Flight Director Brian Smith awaiting a report back from the MER, the engineering support teams from NASA and Bigelow Aerospace working together to determine next steps. And still continuing to stand by for that report from support engineers from NASA and Bigelow Aerospace on what the next steps are going to be. As you can see, though, we do have good sunlight and good video communication, so we could resume the expansion operations should the report come back favorable.
And Jeff, we are still assessing things down here, taking a look at those curves and at the axial and radial displacement. So still a bit of discussion going on in the back rooms, and that's why we're holding. If you like, you could look later in your timeline and grab an activity that you could put down or something short, maybe that CPA activity if you want to try to do something in between.
Okay, I'll go take a look at that. Thanks.
All right, we'll let you know when we're ready to pick back up.
the teams doing a quick video survey of those straps. Again, the restraint straps that were cut in step 2 of our operations today. The engineers from Bigelow Aerospace confirming that all 3 were cut successfully. So continuing to stand by until that report from the mission evaluation room, the support engineers from NASA and Bigelow Aerospace, again, looking at all of the data that's come down so far, the pressure readings, and just how far along the module has expanded both in length and diameter. Again, they have an expected plot with that's being called a pressure curve, where they have expected values for how far beam should be expanding both along its length and its diameter with a given pressure. And so they'll need to follow along with that. Right now, a little bit above the curve at the current stage, so looking at possible options, possible workarounds to continue this expansion procedure. But right now, Jeff Williams standing by on board the International Space Station. The teams here in Houston looking over all of the data and then hopefully coming up with the next steps very soon. But for now, just continuing to stand by. Again, you can see still in the very early stages, just a couple of inches added so far, both length and diameter, to beam from its packed configuration. A total of 68 inches needed to be added for the length for beam to be considered expanded and then be able to move on to that pressurization phase when the air tanks inside of the module will open up and do that final pressurization. But just going to stand by a few more moments. Again, plenty of sunlight, plenty of video communication with the station right now. So if the teams get the go, they'll be able to continue with this expansion operation. But for now, we're just going to continue to stand by for a few more minutes.
Station Houston on 2 for Tim Copra.
Go ahead on 2.
Yeah, Tim, we just wanted to give you an overview of everything that's going on here. We are at the point where we do think we can resume operations with BEAM and begin to press further. However, as you guys know, we have this exercise constraint. So we wanted to make you guys all aware about that. You know, you're supposed to be starting your CVIS exercise now, so we need kind of a summary if you guys are okay delaying that for a while to see if we can resume with BEAM.
We'll definitely delay so that we can resume with BEAM. And I was looking at later in the day so that we can both get our exercise in and meet the constraints for fundoscope. So if you guys can take a look at that for us and come up with a plan that allows us to be able to do BEAM, fundoscope, and exercise, that would be great.
Okay, sounds good, Tim. We will look into that, and we're checking with the Russian crew about their exercise as well.
Okay, thank you.
And so as you just heard from the Capcom, getting close now to resuming the expansion operations with BEAM. Again, the teams from Bigelow Aerospace and NASA evaluating all of the engineering data so far, coming to a conclusion that it's looking like we can resume the expansion operations. So Williams should hopefully be introducing some air into BEAM soon.
Full. Do I need to change it out and initialize another card?
Stand by, Jeff.
And there is a constraint with the crew members exercising on the station while they expand BEAM. And at this point in their timeline, all of the crew members, for the most part, or at least 4 of the 6 scheduled to begin exercise sessions. So the team's looking if they can delay that to a little bit later in the day.
Gig card and get that installed.
Work. The barcode for the second card is 001888802 Juliet.
Houston copies.
And so Jeff Williams putting a new memory card into the camera as they are recording all of these, the operations that he's doing for the analysis teams down here on the ground. And then we should hopefully just be a few minutes now from resuming the expansion of BEAM.
Station Houston on 2 for Tim Copra.
Go ahead on 2.
Yeah, Tim, if you want, you can get your CVIS in now. The CVIS constraint has been lifted, so CVIS is fine, and T2 is no-go, but CVIS is fine. Since that's on your time block now, you can get that started.
Okay, thanks, Jessica.
Okay, thank you.
Station on 2 for schedule.
Go ahead, Tim.
Jessica, just looking at our plan between Tim Peake and myself, he's going to start his JAXA task as soon as possible, and then we get closer to finishing up beam, maintaining the hour for fundoscope. He and I will split the ARED sessions then.
Copy, Tim. Stand by.
Just one more piece on that. We'll have to do that 3 ways. I see Jeff has an hour scheduled as well, so we'll try to work that out.
Okay, Tim, that plan sounds good to us. Thank you. Thanks for being flexible.
Thank you.
And so the team's just needing to work out now the astronauts' exercise schedule, as they do have some tasks later on in this evening. And there is a constraint against a couple of the exercise devices while expanding beam, specifically ARED, the Advanced Resistive Exercise Device, and either of the 2 treadmills on board the International Space Station. So just making sure that the crew members are okay with deferring that exercise for a little bit later while not impacting, or maybe doing a couple of get-ahead tasks, moving some of them up earlier in the timeline so Jeff Williams can go back inside of Tranquility and resume this operation, which we expect to start shortly to be continue expanding beam.
Station Houston on 2 for Jeff and Beam.
Yeah, go ahead.
And Jeff, as soon as we get confirmation from the Russians that Oleg will not start any exercise on Day 2, then we're going to resume the beam inflation.
Copy.
We're hoping to have that momentarily, so stand by and we can get going again.
All right, I'll be standing by.
And again, just confirming that no exercise on the treadmill is going to be started once the expansion of beam resumes. So we should just be moments away now from Jeff Williams once again opening up the valve, getting ready to put more air into this expandable module. So real close to resuming these operations now, just a couple of more moments.
Are you going to want this recorded on video?
Affirm.
Roger.
And this is Mission Control Houston. A quick handover with the communication satellites getting video back just momentarily. And once we do, NASA astronaut Jeff Williams should be getting the go to resume expansion operations with beams. So it's been a bit of a wait. The teams have looked over all of the data just to make sure that they are comfortable to proceed. But it looks like we're in a good position now, and Williams should be getting the call any moment now. As soon as we get this video communication back, look for Capcom Jessica Meir to radio up to the International Space Station, and we will once again resume operations to expand the Bigelow Expandable Activity Module.
Station Houston on 2 for Jeff. We're ready to resume. You can open the port for 3 seconds. That's 3 seconds.
Copy, 3 seconds.
And Jeff Williams getting the call, the time going up 3 seconds this go around. So now resuming expansion of beam.
Our starting pressure is 18.7.
Houston copies.
After 3 seconds, our pressure is 21.2.
Houston copies.
And so with that, the valve open for 3 more seconds. Pressure reading coming down from Jeff Williams. So now the robotics officer will see if there's been any movement in the length and diameter of the module itself.
Scuba station on space to ground 2 for Auxin.
Station Scuba on 2, go ahead.
Good afternoon. I'm looking for a go please in step 1.2 for procedure 2.013.
Yes, you are go for step 1.2 in procedure 2.013. And let me make sure that you have completed the XS305 setup.
That's correct, and I'm going to be working in node 2 at the port MWA area if you want to follow along in the node 2 camera.
Okay, we would like you to use the XS305 camera in GEM.
Okay, Scuba Station, if it's okay with you, I'd like to work on the MWA. It provides a very good workplace for the whole afternoon's activity for harvesting these plants. I've got my setup there with all the harvesting tools, a stable platform, foot restraints, etc.
Checking.
And again, the team's now checking to see any difference in the size in beam following that 3-second introduction of air. And again, so far the module has increased about 5 inches in length from its original 85 inches when it was packed, and about 3 inches in diameter, that original diameter of 93 inches. The end goal's a 68-inch increase in length. And then the diameter will go from 93 all the way out to 127 inches once it's fully expanded.
And Jeff, if you could rotate the multimeter up a little bit, it's at the angle. We're having a difficult time seeing the reading right now. That looks good. Thanks, Jeff. All right, thanks, Jeff. That is a good view. And now you have a go for a generous 1 second.
Copy, generous 1 second. And initial pressure is 21.0.
Houston copies.
Ending pressure 22.3.
Copy.
And so another second of air into beam. The engineers continuing with the expansion operation, giving Williams the go on just a few minutes ago to resume after, again, looking at all the data that's come down so far, the pressure readings, and how far beams, external coverings, everything has expanded so far along all of the operations so far this morning. And as we've done throughout the procedure so far, they're now again taking that pressure reading, looking at the robotic overlay to track how far along the module has expanded, and then using that to then calculate any additional introductions of air for Williams and how long he needs to hold the valve open.
Okay, Jeff, you have a go for 1 more second.
Copy, 1 second with a starting pressure of 22.1.
Houston copies.
Ending pressure 23.7.
Houston copies. And Jeff, stand by. We're assessing the data once again down here, so we'll let you know when we have an outcome.
Okay. Am I imagining it, or did we get about an inch displacement actually?
Our assessment, Jeff, was no noticeable change, so we're still assessing.
Okay.
So the engineering teams, once again, continuing to look at the data. The robotics officer reporting that they're not seeing any noticeable change in this external view of beams expansion after the expansion operations resumed, and Jeff Williams giving 3 1-second introductions of air from the station into beam. And so right now they're just, again, looking over all of the data, determining what the next steps are going to be, and then they'll be radioing that up to Jeff Williams. The team's looking if we're going to be able to continue this expansion process, again, requiring daylight and solid video comm. So there are time constraints that will come into play the longer that these operations go on. But for now, the team's evaluating next steps once again. Jeff Williams standing by on board the station, and beam expansion still continuing. So continuing to stand by while the teams look at this data. So again, the engineering teams here in Houston, both those at NASA and those from Bigelow Aerospace, looking at all of the data that's come down so far. Beam's expansion, we started a little over 2 hours ago. Only a few introductions of air into the module so far. With the last 3, the robotics officer reporting no noticeable difference in the length and diameter of the module itself. So they're, again, looking over their procedures, what potential workarounds, what next steps they can take to see if they can continue these operations. Again, we do require sunlight and solid video communication for all of these expansion operations to begin, and we still will start to run into some time constraints, especially as the current team on console, the Orbit 1 team, is getting to the end of their shift with that team led by Flight Director Brian Smith, who's been overseeing all of the planning for the ops team here in Mission Control Houston for this expansion. But for now, we're just standing by, waiting as the teams continue to discuss what these next moves are going to be. Jeff Williams standing by on board the International Space Station. Again, those first 3 steps taken today, which were done automatically through the beam expansion controller, closing the ascent vent valves, cutting the restraint straps, and releasing the forward bulkhead, done successfully. And we're in step 4 or 5, this manual expansion of beam. And Jeff Williams has introduced air through a series of anywhere from 1 to 5 second spurts, air flowing from the International Space Station itself into the Bigelow Expandable Activity Module. And again, as this process unfolded, Williams would then take pressure readings, feed those down to the ground, who would then compare that against the changes that they saw in beam shape, and then decide how long to introduce air on the next step.
Station Houston on 2 for Jeff.
Hi, Jessica.
Yeah, Jeff, unfortunately, we're going to have to stand down with the beam operations today. We've been assessing all the parameters here from the ground, and due to our set of no-go conditions and not seeing any noticeable movement, we're going to have to reassess further from here. So we have a couple of actions for you to take to get us in a good position for that. First of all, we'll need you to cap the ISA sample port.
Complete.
Okay, great. That will get us in a good config, and then you can stop recording then if you haven't already. We may later on, we'll get back to you, but we may have you swap out those multimeters. And then just to give you a big picture, we're hoping to resume with inflation tomorrow during Orbit 1, but we'll have a status for you guys in evening DPC with follow-up there.
Okay, I understand. And I took the initiative since the controller is powered off, the KU power supply I powered off, and because we have a lot of potential energy on the other side here, I chose to drag that thing back into node 3. So I'm going to leave it in node 3 so we don't have a drag through, if you concur.
Okay, Jeff, good move. We concur with that. Thanks for all of your patience today, and we'll hope for better luck tomorrow.
Well, these are the kinds of things the team is up for the challenge for. It's space business. So thank you all for your patience.
Okay, we agree. Thanks, Jeff.
And so with that, you just heard Capcom Jessica Meir calling up to Jeff Williams that we are going to stop the deployment operations for today. The teams, the engineering analysis teams on the ground, not seeing the expansion that they were expecting along with the pressures, along the pressure curve. So operations called off for now so they can continue to assess all the data that they've seen so far and then come up with steps. And as you heard, Capcom saying hopefully resuming tomorrow, but obviously that will be decided later in the day after all of the engineering teams are able to meet and then discuss next steps and how early they can give it another shot to try and expand beam. So obviously we will keep you updated on all of our different platforms on nasa.gov and across our various social media accounts where we stand with beam expansion and whether or not those operations will resume tomorrow or at a later date, as the teams again will meet over the next several hours, discuss next steps, and figure out when we will again resume the operation to expand beam.
We'll still want that set up for tomorrow, so you can leave everything as it is.
Okay, I understand. So the only thing I have left to do here is put ARED back in operational order.
Stand by one on that, Jeff.
And just a final recap on the day's operations, those first 3 stages of expansion today, closing the ascent valves, cutting the restraint straps, and releasing the forward bulkhead, done successfully, and the crew getting a little bit hung up in step 4, that manual inflation that, again, the teams are going to go forward, assess down here on the ground, and then come up with the next possible steps. We may be returning to operations tomorrow, but again, that will be decided in the next several hours once all the engineering teams from NASA and Bigelow Aerospace get a chance to meet and discuss what the path forward will be. Again, we'll be bringing you updates on any coverage times or any media availabilities or media teleconferences on nasa.gov, so be sure to just go to the homepage, look in the latest events, and be sure to follow along. As not able to get everything done today, but we'll again regroup, look at next steps, maybe back tomorrow, but we'll return again to expand this, the first human-rated expandable module to ever be flown in space. But for now, thanks for sticking around with us this morning, and we'll be sure to be back again soon here on NASA TV. But for now, we will go ahead and sign off. This is Mission Control Houston.